Hi, and welcome to grades 3 through 5 Eureka training. My name is Troy Hobson. I'm a 5th grade math teacher in Kenner, Louisiana. This is my 10th year of teaching math, and I'm in my 2nd year of fully implementing Eureka. And I'm really excited to be here with you all today because, one, I've seen how transformative Eureka can be as a really useful curriculum, and two, I've seen some of the results that students can get if it's implemented correctly. So today we're going to be working through some of the ways that you can really successfully implement Eureka into your work. I want to start off by doing some models and using some manipulatives and pictorial models to help understand some of the mathematics. So first question, what is the value of using pictorial models or manipulatives in your mathematics practice? Yes. So yeah, definitely students enjoy it, it's fun, it's engaging, but what else? What's the value in it besides just engaging students? Understanding the why, exactly, right? Kids can understand why something works if they're able to use pictorial models and manipulatives into their practice. So what we're going to be doing right now is using some place value disks, these guys, which are a really important tool in Eureka, and we're going to be solving a multiplication problem, 3 times 23. So if y'all can write that down on your place value charts and get out your place value disks, we're going to be using them to model this problem. So the first thing we have to do is decompose 23 into unit form. So what is 23 in unit form? 2 tens and 3 ones. So you can make 23 on your whiteboards. And then since we're showing 3 times 23, we're going to want to make 2 more copies of 23. So we will literally have 3 23s. And I'll give you all a second to get that done. And while we do that, we can also write that down vertically so we can kind of draw this connection between the model that we're making and the actual picture, or in the actual vertical algorithm. So 23 times 3, and then I have my 3 copies of 23 right here. So the first thing we want to do with this, now that we made our model, is actually multiply the value of each place. So I want to figure out how many ones I have first. I have 3 times 3 ones, which is of course 9 ones. And then 3 times 2 tens, which will be what? 6 tens. There. Or if I'm showing on my standard algorithm, that looks like 3 times 3 is 9. 3 times 20 is 60. And when I put those two values together, I'm going to end up with 69. So what is the value of actually showing this problem on a model like this? Okay, yeah, definitely. It'll help them understand how this actually connects to the standard algorithm for sure. Yeah, it shows repeated addition, right? 3 sets of 23 equals 3 times 23. So it helps understand why that works. There's one more thing. Are there any 3rd grade teachers in here? So what does this end up looking like then? Yeah, what this is, it's literally an array. So it helps kids draw this connection from their 3rd grade learning into what they're doing now. So there's a lot of value in using these manipulatives, but eventually you need to move past the manipulatives and do something a little bit quicker than getting out all of these place value disks. So we're now going to solve 4 times 34, and this time we're going to use what's called a chip model, which you're probably familiar with, but if you're not, basically it's drawing place value disks instead of using the physical ones. So let's first write down 34 times 4. And we're going to, again, break 34 into unit form. So what's 34 in unit form? 3 tens, 4 ones. And since we're multiplying by 4, we have to make 3 more copies of 34. So we'll end up with 4 30s and 4 4s. And while you're catching up, can anyone tell me what's different about this problem than the last one, besides the fact that we're using a chip model? Yeah, right, we have to regroup, right? So if they're unfamiliar with multiplication, or all they've seen is a standard algorithm, they might set this up like this: 34 times 4, 4 times 4 is 16, 4 times 3 is 12. And be confused about the place value understanding that goes with multiplication. The value of a chip model is it helps take away that confusion for students, right? So they'll be able to recognize, hopefully, that 4 times 34 is the same as 4 times 4 ones plus 4 times 3 tens, which would be 16 ones and 12 tens. And the beauty of Eureka is that they've been working with chip models or similar things with regrouping in the past. So this should be familiar enough for them to say, oh, look, I have more than 10 in a single place. I need to regroup that into a larger place, right? My 10 ones here are going to regroup into 1 10. And my 10 tens will regroup into 1 100. And then this helps them actually draw that connection between how they're using the standard algorithm or how they're using vertical multiplication and what the actual model looks like. Right, 4 times 4 is 16 ones, 4 times 3 is 120 or 12 tens. When I add that together, I'll end up with 136. Now, how is that shown in the chip model? Well, we have 1 100, we have 1, 2, 3 tens, and we have 1, 2, 3, 4, 5, 6 ones. So 136 is our final answer here as well. And just being able to set this type of problem up is a way that can help students avoid this place value confusion that sometimes comes with early multiplication. So it's a really valuable tool for students to be able to use to help reinforce some of the understanding that goes along with this mathematics.